Hello grade 9s, Mr. LaRusso here with another example of kitchen physics. We're going to do some more fun experiments that you actually can do at home with electrostatics, and we're going to make our own homemade electroscope. And here's what we're going to use. We're going to use that same piece of hard styrofoam that I had kicking around the house, but we're also going to use some very simple material. What I have here is two aluminum foil pieces made into balls held up by a piece of thread on a hook. Now the key thing is I want these things to be free floating in air, and this is going to demonstrate the concept of static electricity. Specifically what we're going to do is something called charging by contact. So let's take a look at the current setup. What you can see is that the two aluminum foil balls are sitting in contact with each other. They're being held down by the force of gravity. What I'm going to do is I'm going to use this little piece of styrofoam and I'm going to rub it against my shirt like I did in the last video, and I'm going to generate a static charge on this, and then I'm going to transfer some of that charge to these objects, and watch what happens when I do this. When I bring it in close proximity, you can see that the closest aluminum foil is moving towards the styrofoam. And that's because we are inducing a charge inside the balls themselves. What I'm actually showing here is something called polarization, and I use the word induced. Now let me show you what I mean by induced. Notice the rod here is positive. When I bring this positive rod in, it draws the negative charges over to this side. This is what we call by induced. So now, the reason why is this side is now induced positive, this side is induced to be negative. So we call this polarization. So now this explains what happens on those two aluminum pieces that are being held by the string there. When I bring this in, when I bring the positive in, it draws the negatives up, but the two legs are positively charged, so they repel each other. And that's the same thing that's happening with the two pieces of aluminum. So what that means is the negative charge buildup on the styrofoam is causing the electrons to move to the other side of these pieces of aluminum, which means that the more positive end is being attracted. So as I bring it closer, the force gets stronger, and then eventually they touch. Now, the moment that it touches is the moment that we got some charge transfer. So we're going to explore this idea a little bit. What I'm demonstrating here with the pieces of aluminum is something called charging by contact. You could see that the styrofoam touched one of the pieces of the aluminum. The big idea is this. When we have a charged substance, like in this case, we have two types of charged rods, a positive one and a negative one. In our experiment that I was doing in the kitchen, I was using styrofoam. What's going to happen is some of these charges are going to transfer to this thing called the electroscope. And this electroscope is essentially the same thing that I've demonstrated with the two pieces of aluminum hanging from the thread, and when contact is made, we saw that the two pieces of aluminum separate from each other. So here are some examples of some charged rods. So this one is positive, this one is negative, and this one is going to be neutral. Let's start off with the neutral one. When I bring the neutral one in close proximity, nothing much happens. But watch what happens when I bring the positive one. When I bring the positive one in here, as you can see at the very top, we have some negative charges being pulled up. And again, we talked about that polarization or induction. So right now the electrons are being attracted throughout the entire electroscope, and they're being drawn up, which means the bottom of the electroscope, the legs down there, have been induced to become positive. Now when I touch it, some of these electrons migrated over to the positive rod. As a result, the net charge on this thing is positive, so that means the legs are positive. And these are like the two pieces of aluminum that I had. They both have the same charge, and therefore like charges repel each other. And then we can bring the positive rod again, and then we can even steal more electrons. And the more electrons that we steal, the further the legs separate, or in our case, the pieces of aluminum. So now we can do the opposite. Now we'll bring in the negative charge. When I bring in a negative charge, that induces the top to be positive, which means that the electrons are being forced down below, and that's why the legs separate again, but this time the legs are negatively charged. If I touch it, then we have some negative transfer. If I add more charge, they should separate further, and the more charge I add, the further they go. Now, this is an ideal situation. Of course, the problem is this. In the environment, especially in the summertime, we have a lot of humidity here, and that humidity causes these charges to not be isolated on the electroscope, but they'll actually jump onto the bits of water that are absorbed into the atmosphere. So it's very hard to keep a charge. And we'll add more charge. And now you can see the force of repulsion because I have transferred some charge. Now, the more charge I add, the further they should separate. Hey folks, so I had to modify the experiment a little bit. It was a little too humid upstairs, and as a result, it was really difficult to hold the static charge. So I've modified the apparatus a little bit, and let me show you what I did. So I've swapped out the materials. As you can see, I have copper instead of aluminum now. Copper is a conductor. However, it's being held up by this thread, which is an insulator. So what we're going to do is I'm going to very carefully charge it using the same styrofoam, but this time my very, very staticky hoodie. So you can see the repulsion there. You can see that they're forced away from each other. A little bit of separation distance. Now I'll try to charge it up again. And you can see that they're being repulsed from each other. And there is the force of repulsion. Now slowly that charge buildup is dissipating into the environment because the house is a bit humid from all that rain that we had yesterday. This works much better in the winter, but still not bad. So I've made a modification to the setup. I actually increased the size of the aluminum bits. And the thought is, with a larger size, they should be able to hold more charge. And now, when we charge them up, lo and behold, I think we have an improvement. So you can see a significant amount of separation. Let's try to add even more charge. Now that's a lot of force. Love it when it works out.